Welcome back for another episode of the 5G Guys. I'm Wayne Smith and joined by my co-host, Dan McVaugh.
Hey everyone, welcome back for another episode. Excited about today's guest. Today we have Ignacio Contreras from Qualcomm's Technologies Incorporated. Those familiar with wireless technology and the industry know Qualcomm quite well, but those that are not, you should know that Qualcomm is basically on the Mount Rushmore of wireless technology companies. So we're super excited to have Ignacio. Ignacio is the senior director of product marketing at Qualcomm, where he leads a team responsible for the company's 5G, RF and infrastructure, AI, gaming, multimedia, Wi-Fi, Bluetooth, and technology licensing. So he's got a lot of responsibilities there and be able to talk to a lot of great stuff with us today. He joined Qualcomm in 2009 in support of their expansion of 3G and 4G businesses in both automotive and Internet of Things. Prior to his current role, he managed media and analyst communications in support of the automotive and Internet of Things businesses. Ignacio went to school getting his bachelor's of science in industrial engineering and a master of engineering at sciences at Catholic University in Chile. And he also has an MBA with an emphasis in technology strategy and marketing from UC Berkeley. So quite the credentialed guest today, Ignacio. We're excited to have you. Welcome.
Hello, Dan. Hello, Wayne. And thank you so much for having me here.
You bet. Let's start off with Qualcomm. Tell us about Qualcomm. Give our listeners a bit of a history of what the company is, what you guys do.
Well, I can tell you that Qualcomm is probably one of the most important and most unknown companies in technology, particularly relevant when it comes to wireless and mobile technology overall. The company was started in San Diego, California, where I'm based now, in 1985. It was created by seven founders who sold another company, another venture before, focused on communications for the defense industry. That's why we're here in San Diego, because there's an important defense industry here. So the prior company the founders had, it was based here, and that kind of set the roots for what's now Qualcomm. And they started without a lot of knowledge. We have like several kind of PhDs and MIT professors there, but with no clear business plan. They just got genius people and say, let's do something else together. So the first business that the company had was, in fact, nothing related to mobile communications. It was tracking, kind of a satellite tracking systems for trucks, right? For mobility overall. And that business was fairly good. It was a fairly profitable business, and that funded the R&D for the company to then enter into a wireless communications for cellular. The main breakthrough of the company and what it makes the company fairly famous for in terms of the history is the technology called CDMA, Code Division Multiple Access, which was a fairly novel technology that was implemented in 3G to be able to pack a lot more voice calls and texts and start sending data over cellular networks. That became the mainstream technology for all 3G networks, and then 4G, and now we're going to 5G as well. So in the 90s, the company started building everything because the technology was so new that no major companies were keen on investing in such new technology. So you have Qualcomm building, of course, not just the R&D, the designing the wireless technology that was going to be used, but also building phones. So there are Qualcomm phones back in the 90s, building cellular base stations, those antennas and that you see out there that connect our phones to the base stations, and building chips even for mobile phone. And that set the path for what the company is today. The company started becoming a large semiconductor company for the mobile industry, and now famous for what's called the Snapdragon processors. The company divested the cell phones, the also the infrastructure business, but focused on all the R&D and for mobile devices, and then of course set the base for what's now 4G and then 5G technology as well. Expanded into what now is not just the cellular communication, but all the key technology that you have in your mobile devices. So multimedia, AI, Wi-Fi as well. So if you have any of the listeners here have a a phone, right, in your pocket or in your purse, very, very likely you have a piece of Qualcomm technology in there. And now it's one of the major forces in the development and commercialization of 5G, and also expanding into not just mobile phones, but also automotive, Internet of Things, PCs, you name it, a lot of areas where Qualcomm has the footprint. So hopefully that provides a bit of a background of what the company is. Again, one of the largest and probably most unknown companies in the tech space.
Yeah, that's awesome. Basically, if you've got a mobile device of any kind, whether it's a phone or a Internet of Things device, it's a Qualcomm device most likely, especially in the United States. Who would you say is one of your competitors in that space? Would that be Samsung possibly, or who else kind of does what you guys do?
Yeah, it's interesting because there's a lot of what are calling these frenemies here or operation competition. So, for instance, companies like Apple, right, or Samsung, they, of course, are customers of Qualcomm, buying some of the chips that power either the cellular communications or the entire phone system, but also they work to create their own chips overall that also power their own devices. You have companies like MediaTek also that they, like Qualcomm, produce and um, distribute chips for phones. And you also companies that do R&D, just like Qualcomm, that invest in the fundamental technology that creates 4G, 5G, AI, and other technologies. And you can talk about companies like Ericsson, Nokia, Huawei, that are very strong in developing fundamental technology, but also our partners, right? Because phones need to connect to infrastructure, and those companies provide infrastructure as well. So it's a somehow convoluted picture, but then it's a testament of the technology environment in general, where you need to cooperate and cooperate at global scale to make things like 5G happen. But also, it's very active in terms of competition and bringing devices and the best technology very quickly to market. Faces to the people, right? And you see their work. And for the most part, I would say very humble, friendly, but brilliant people that at the end, all together, are building these kind of things, one contribution after another, one improvement after another. It's a very humbling experience for me. It's not just one brilliant person, it's not just one.
Hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations. For over 17 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's vertex-us.com.
When you think of the mobile device and how far they've come, and for a lot of listeners, one of the things they use their mobile for is gameplay. And so what's Qualcomm's, how does it enhance gameplay over the mobile device? Because, I think we see more and more games on our devices, and tons of people love that part of the technology.
I love gaming because if you look at a mobile device, probably the user experience that stress most technology, and not just connectivity, but also the graphics, the sound, the whole experience is gaming overall. So lots of efforts to create the best gaming experience here from Qualcomm, from Snapdragon chips, because if you create a great gaming experience, very likely you will create a great experience for many other things that you do with your phones or your PC or any other devices. So lots of emphasis on the graphic processing unit, kind of a developments in terms of how you can further increase the resolution you can sustain, like even 4K or up to 8K resolution, but also how many frames per second, right? You can process now going into 144 frames per second. The things that used to be kind of only on the realm of PC gaming or console gaming overall, in terms of sound as well. So how you create technology that when you're using your Bluetooth headphones, the latency, right, is still not an issue. So you can hear real time what's happening. And same with connectivity, right? Particularly as you're playing cloud gaming overall or multiplayer gaming, latency is very important in network communication. Maybe not necessarily just all the data speeds, but the responsiveness of the network is key. because if you're playing a game like Fortnite, right, for instance, or Call of Duty, uh, a few milliseconds of delay in your control responding might be the difference in terms of winning or losing. Like basically, you're alive or dead on the game. So there's a lot of effort that goes into the gaming technology overall. But I was really stressed because a lot of that, if you can shine on gaming, there's a good benchmark that you can provide a good experience just watching your videos or listening to your music or just browsing the internet is probably one of the highest bars that we can find in terms of technology development for mobile devices and other devices overall.
Yeah, it's interesting you mentioned that because I've done some looking at some of the stuff going on with augmented reality and virtual reality, AR and VR, and I understand that the latency thing is a big issue with VR and AR because if the human body, for example, turns its head and the application has too much latency, it can literally actually cause the user that's experiencing that to get physically ill or get vertigo, right?
Yeah, and it's super complicated, in particular in the case of VR or augmented reality glasses. It's a big challenge because you don't have much space in the device. If you have a pair of glasses, you don't have much space like you have in a phone to put chips, to put battery, to put all those elements. So, for instance, one of the things that our engineers have done here to achieve those challenges and put all this technology into a much more limited space is to split the chips. So, what you do with one chip, let's say one main system on chip or processor in your phone, it can be done maybe with 3 or 4 chips in your augmented reality glasses because you need to put one piece in the glass, one piece on the sides, some pieces on the front, so you can basically distribute all the technology without using much space and still be able to provide all those technologies that again, it's graphics, it's low latency communications, it's a lot that goes in there.
Yeah, interesting enough, when you talk about chips in the mobile device and, things have gotten smaller for sure. I did see that, Qualcomm's chips, I think we underestimate the power of those chips of like, I, and I don't, you might have to correct me on my terminology, but like one chip might have 2,500 different functions in the phone and things or modems within that chip. Is that correct? Because it's really got smaller over the years in the newer phones, but it does so many things for the phone, from the camera to different sensors and applications of the chip.
It's what you have in your phone now, and basically what I use in my hand to watch cat videos or other videos on the internet, you have more compute power than supercomputers from 20 or 25 years ago. What only just the top scientists access at that time, it's basically in a lot less than a lifetime overall. So the amount of power is impressive. And even you compare like what you can do with your phone versus what you can do with computers, gaming laptops or very advanced laptops, but on things like audio, on things like display, even you can see with the cameras on phones are of course a lot better, right? And pack a lot more technology that camera on a PC. And particularly we could see a lot of that with the pandemic, right? Because when everyone was on a video call or video meetings, you can see, oh man, the camera in my laptop is not really that great overall. So yes, it packs a lot of power, and the challenge is how you can pack all that power and technology with such limited battery, right? It's just the amount of energy that you can pack, of course, in a phone. It's very, very limited, even more if you talk about augmented reality glasses or IoT sensors. So, how you design technology that it's not only be able to play your games at 144 frames per second, run your AI models on the device, take and process all these images and pictures that you can take and with several effects and capture video high resolution in a piece that still fits in your hand and can last the full day, if not more, in terms of battery. So the combination of the two things, very high demanding technology, but very low use of power of energy, it's nothing short of amazing or a miracle that engineers all over the world have been able to achieve. It's just an unsung hero of technology, what these little machines can do for us today.
Yeah, absolutely. We've talked about, being the podcast called 5G guys, and on the topic of 5G, we've talked about how, where we're at today really started in a lot of ways in my opinion by the advent of the first iPhone, right, back in 2007. And it gave users this new experience of it's not just a phone anymore, it is a computer in your hand. And that really prompted a lot of what we have in our 4G and 5G standards today, because it was now demand by the user put on the device, and the device had to catch up, right?
Yeah. And now we see that with a new wave, with you see with generative AI. For instance, I think one of the most amazing things I have seen, right, in the last few months is you see, of course, most people now is familiar with ChatGPT, right, or these generative AI models. There's another one called Stable Diffusion that you can put in a box, right, in a text box, a small prompt like I want a cat playing soccer against dogs in an island, and it generates an image for you on that simple prompt, right? That's generative AI. All of that until 6 months, right, from now or 3 months from now, is used to run on big cloud servers, right? You need farms of servers that can process all the data, run these models, and be able to generate and translate that small prompt into an image, right, or just a response. And now we can do that in our phones only, right? Even in airplane mode. So Qualcomm demonstrated a few months back in a big conference, Mobile World Congress, the first implementation of Stable Diffusion, this ability to turn prompts into images, high quality render image, only on an Android phone without any reliance on the cloud overall. So that goes back to Dan's points, right? In terms of how much power now we have in our hands into these devices, even in something that recent as generative AI, who now we would see have been running so far only in big cloud servers. Now you can run it into your phone, and we'll see more of that. It's nothing short of, I think, magic in
That's
terms of what these
amazing.
little devices can do.
That is so amazing, and the impact of that, we've talked in other episodes about edge computing. I mean, that is edge computing at its core, what you just described, right? We now take the need for the 5G network out of the equation in that use case, right? We don't have to push all this data back and forth over the cellular network to support that use case. It's all done right there locally in the user device. It's amazing.
Yeah. At the end, what you will need is the combination of both, right?
Mhm.
What's happening, particularly generative AI, is that the amount of processing that's required to translate these small prompts, conversations into images, into responses, it takes a lot of compute power. If you take the example of search, right, doing a traditional search, web search, versus doing a generative AI search or something like ChatGPT does, it takes 3 to 7 times the cost, right, of doing a generative AI versus doing a traditional search overall. Imagine that impact in the bottom line of web search companies. It's major. If you say, oh, everyone will start doing generative AI search instead of traditional search, and my cost will increase 3 to 7 times, that's not good, right, for investors. So, what probably will happen is that you will see the loads distributed. So you have some searches that you will be able to run, and the phone will be able to resolve that. If the search becomes too complicated, then might rely on the cloud, or the cloud will somehow be verifying, right, what the AI model in the phone is doing. So, okay, we have our questions, search the web, translate that, digest that into a generative AI response. If the response is good, the cloud will say, okay, that's fine. If the response needs improvement, okay, the cloud will take care of that. But you will need to distribute the load. Otherwise, what we're seeing with Jitter will not be scalable at global level, just using cloud farms overall.
Yeah, that's pretty amazing. In a use case, this happened last week at my company. We were doing a marketing meeting, and we had 6 individuals in the conference room, where in the past they would have had their laptops, but we all had our mobiles, and we developed using ChatGPT. I would say 20 pages of new content generation within minutes in this team, and everyone was collaborative in their own prompts. And so the end result was we were super efficient in the room. We did not use our laptops only as a note taker. And we were all on our mobiles interpreting the content for the marketing campaign in real time within minutes. And so the productivity that we got back and the time that, this technology does and the speed of it, I think it's pretty, it's just amazing how much time you win back in your day that you can do on other business tasks or other task periods. So pretty amazing application of the phone and the processor in it in order to do that. And we're seeing it in the bottom line results of our company in real time right now already.
And another aspect that is important, what you're mentioning, Wayne, is aspect in terms of privacy and intellectual property protection. We already seen examples in the press, right, of companies that have blocked access to ChatGPT because they're concerned that if programmers are using ChatGPT to refine code or debug code, then okay, who is the owner of the resulting code overall? Or am I exposing my deepest secrets and secret sauce, or what will be my next product into the public, right? Because the ownership of that data that's produced might be unclear. So we see now companies even forbidding, even entire countries like Italy, right? Kind of forbidding the use of ChatGPT, or let's say pausing the use of such technology. So it's important also that we have a ways to turn some of these capabilities, not just from the cloud into the device itself, not just the phone, but also can be the PC, can be the car, can be others, because also there's some privacy and security implications or preferences on that. And so again, we will not be able to scale these capabilities using only cloud servers. You're right, Wade, in terms of the level of productivity that it can bring is amazing, but imagine the entire world using the same kind of capabilities, it doesn't scale. We need to put the cloud to work, but also we need to put the edge devices to work to make this happen.
That makes sense. It makes sense. I want to circle back a little bit to your introduction of Qualcomm and how you basically explain that at the end of the day, Qualcomm is one of the major players in the R&D of the technology that we have today and that we'll see in the future. And as part of that, that means you guys play a role in the development of the technology standards themselves. So, for example, the 4G standard that everything was developed around, and now the 5G standard everything was developed around. You guys play a significant role in that, correct?
Yes, one of the key, I'll say, aspects of the company DNA is R&D. Remember, that company was founded right by academics and kind of a PhDs. That carries a lot of what the company is today in terms of the emphasis on doing R&D across all levels, let's say of 5G, right? Not just the device, but the network, system architecture or so. And the way to scale that and turn that at the end into products and a system that works everywhere is standardization. So the company, Qualcomm, is very, very active in a 3GPP. That's the international organization that takes care of the development of specifications for cellular technology. 3G first, that's why the name is 3GPP, 3G Partnership Project. But that project was so successful that extended into 4G, 5G, and in the future will be 6G. There are discussions on what 6G will be. And yes, Qualcomm and any other major company in cellular communications play a big role in that organism, because that will define what will be the future for our cellular communications or what is today.
Got it. Got it. So in that regard, then, a lot of what we hear from listeners, other guests, is this discussion about, we all experienced the transition from 3G to 4G and how impactful that was, the use cases that came with it, as consumers, how it changed our lives. And then we hear a lot of people talk about, well, 5G, it's not turned out to be what we thought it was going to be. And I think there's this misperception of what 5G was intended to be, as well as what we're currently experiencing. Can you speak a little bit to your perspective on that?
Yeah, I can speak a lot of that. So keep me brief, Dan, on this. But at the end, yes, for people who was being exposed or was able to always have the latest and greatest and 4G, 5G feels about transitional than transformational. But in many aspects, or for many other people, 5G has been a real change. And let me give you a few examples, because the numbers telling another story. Let's take example just in the US. In the US, the amount of data that has been consumed and increasing, right, in mobile networks in the last 5 years has grown about 4 times. So today, roughly, we're using 4 times in mobile networks the amount of data that we were using 5 years ago, a little bit before the pandemic. Imagine if this was the highway infrastructure. Imagine that if in 5 years we'll increase by 4 times the number of cars and trucks driving through the highways and freeways. It will be a mess, right? Things will come to stall. But with cellular network, no, everything is running still very fine. Why? Thank you 5G for that. There's also other kind of measurements doing by companies like OpenSignal, who basically collect and process information from the cellular network performance on the field. And they have basically measured significant enhancements in mobile experiences, particular video, right, and speeds across the United States and other countries. Now, of course, we have, for instance, social media. We have evolved social media from being just mostly text, like the early days on Facebook and some pictures, to some pictures and video. And now we have things like TikTok that are pure video, right? People uploading the videos, people consuming the videos all the time, and they work just fine. If you switch those experiences today, even from 5G to the 4G network, the experience will not be the same. For gaming, what Wayne was mentioning there, also there have been measurements of how 5G, particularly millimeter wave, is beating things like public Wi-Fi, right, in terms of performance. So remember that apps used to train us to say, hey, if you're going to use data, switch to Wi-Fi should be better. But now you are in a coffee shop, your 5G might be a lot better than your public Wi-Fi overall. And things that were unthinkable, right, with G, things like replacing the connection that you have, fixed connection that you have to your home. With 4G, it was not competitive to replace cable, right, or to compete with fiber or DSL in providing internet access. But if you watch the last Super Bowl, you saw T-Mobile doing a big marketing push, right, with John Travolta, making fun, right, of the cable companies and publicizing, investing big on their 5G home internet service, because now the technology allows companies like Verizon, like T-Mobile, not just satisfy the needs of mobile devices, but also provide internet access and bring in more competition to that space. And this is just the beginning, right? We are just 3 years into the deployment of 5G, something that will keep growing for decades. So we still have to see the impact that will have in augmented reality, with private networks in enterprises and productivity, more PCs. We're just at the beginning and we're seeing big changes. So yes, if you had a very great 4G phone and you transition to a 5G phone in a area that's affluent and very well covered by the network, yes, your increase and your change experience was a bit more, I'll say, evolutionary. But for things or countries like India with fixed wireless access, or for other people, even access unlimited data plans. And limited data plans were on pretty much disappearing by the end of the last decade. And now they have seen a resurge in unlimited data plans from all major carriers, because now they have capacity because they have 5G. So even
Right.
your wallet is benefiting from that. I told you then I can speak a lot on this topic. I have my passion points on this. And yes, I can see how for some people with access to good networks and good phones, fields don't feel much revolutionary, but the data states otherwise.
That's a good point. That's a really good perspective. As you know, in the past, when we would go from 2G to 3G, and before we went from 3G to 4G, there was these what I'll call point releases, right, where there was enhancements to 3G that were, significant improvements, but they weren't as transformational as going to 4G. And then the same thing happened again within 4G. Are we seeing, or are we on the precipice of something similar within 5G? I understand there's, 5G advanced, for example. Is are we going to see some significant improvements within 5G prior to 6G? And what might those look like?
Yes, taking history, right, as you mentioned, as a example or to provide perspective, the 4G on 2020, let's say by the end of the last decade, was very, very different from the 4G that we had at the beginning, right, of LTE, let's say on 2010 timeframe. So in the span of 10 years, the technology evolved a lot. Peak speeds went up about one order of magnitude or so with the technology. We saw things with 4G like carrier aggregation, so ability to bring together more spectrum frequencies. It's like building more freeway lanes, right, to put more data as well. Uh, Technology that ability to use multiple antennas, so be able to send multiple streams of data at the same time using the same frequency, and even going on the other side of the spectrum, downsizing the technology to be able to support IoT devices, what called LTE-M or LTE and BIoT. Basically, LTE downsized in a way that can be put in a smart meter that need to last several years, right? Running on the two AA batteries. All of things were evolved, and what we saw at the end of the development of 4G was very different from the 4G that we saw at the very beginning, and we will see the same with 5G. In a couple of years, we will see the launch of 5G Advanced, which will bring many new capabilities like the ability to use even more antennas, the ability to use AI, right, to be able to predict, right, what will be wireless conditions, and therefore be able to allow the system, both the base station and the device, to improve communication and at the end improve speeds, improve coverage. And we will see developments on 5G configurations to serve augmented reality and virtual reality devices. And also something that to me was amazing, that using 5G for things that are not even to send data, using 5G, for instance, for positioning. So if you have, let's say, in a city, a port, or a manufacturing plant, and you can identify the location of robots or people or assets using 5G infrastructure. That's not about sending data back and forth. It's just about using the signals and the infrastructure and devices on 5G to be able to understand where on earth are these devices. All those things are being considered into what's 5G advanced. And I should tell you, if history is a precedent, that will be a harbinger of what we'll see with 6G. Specifications for 6G have not started being built. There's an early discussion in the industry, but still the idea of what 6G will be exactly, it's a bit fuzzy, but probably looking at 5G Advanced will be the best harbinger and the best predictor of what will end up being built into what will be 6G specifications.
So Wayne and I are safe to call ourselves 5G guys for a while, and we don't have to switch to 6G guys anytime soon, hopefully.
I'll start thinking about that 2025 or so.
Okay.
And then maybe when's the right time to transition the name, or we may have to be 5G is like 6G guys for a while.
Yeah. It's pretty amazing hearing you talk, and really for someone who's been in the industry like Dan and I to understand your contribution to wireless technology over the years. As I sit and look, I researched this morning the Snapdragon 8 Gen 2 processor, and I looked through the specifications and capability in that one processor. It's really a combination of every technology that we use wirelessly, from Bluetooth to Wi-Fi to cellular. It's super amazing of the contribution that Qualcomm has made within the industry and continues to make within the industry.
And I want to be very humble here because, of course, it's not me, right? It's the company. But the end, from my perspective, has been a pleasure. At the end, you see the faces of people, right? At the end, you see the engineers working long hours, doing their presentations, very passionate about making one small contribution to the specifications that they feel will change things. So when you put effort, it's a lot of very humble people working very long hours and discussing a lot in a very academic, I'll say, fashion, how to make things better. It's very rewarding on my end.
Well, we really appreciate you taking a few minutes away from your focus on all that R&D and all that amazing work you guys do to chat with Wayne and I and our listeners. And this has been an amazing time with you today. And we can't thank you enough for taking the time to talk with us and educate us and tell us, everything that Qualcomm has going on. So Ignacio, appreciate it. Thank you so much. And we look forward to staying in touch and hearing more about what you guys are working on.
It has been my pleasure. Thank you so much, Wayne. Thank you, Dan.
Thank you.
Take care.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.